What does it take to create a fighter jet that can dominate the skies, strike targets with precision, and operate seamlessly from the deck of an aircraft carrier? The McDonnell Douglas F A-18 Hornet embodies versatility, power, and innovation. Today we dive deep into the story behind this iconic multi-role combat aircraft, exploring its origins, unique design features, operational history, and lasting legacy. From its beginnings as a derivative of a lightweight fighter prototype to becoming a backbone of U.S. naval aviation and beyond, the Hornet's journey is a fascinating tale of engineering and combat excellence. The story of the F-A-18 Hornet begins in the 1970s, a time when the United States military sought to modernize its fighter fleet. The U.S. Air Force had initiated its lightweight fighter program, aimed at producing a highly agile, cost-effective fighter to complement its heavier, more complex aircraft. Northrop's YF-17 Cobra competed against General Dynamics' YF-16 Fighting Falcon. Although the YF-16 won the Air Force contract, the Navy saw potential in the YF-17's design for its own needs. The Navy's requirements were more demanding: a carrier-capable, multi-role fighter capable of both air-to-air combat and ground attack missions, roles traditionally handled by separate aircraft. McDonnell Douglas partnered with Northrop to adapt and evolve the YF-17 into a versatile platform fit for carrier operations. This collaboration led to the birth of the F-A-18 Hornet, with F-A signifying its dual role as a fighter and attack aircraft. The name Hornet was chosen to reflect its agility and sting. The first prototype flew in 1978, and after rigorous testing and refinement, the U.S. Navy accepted it into operational service in 1983. The Hornet was designed to replace aging aircraft like the A-7 Corsair II and F-4 Phantom II, which had served valiantly but were becoming costly and less effective in modern combat scenarios. The U.S. Marine Corps quickly followed suit, adopting the Hornet for its own aviation units. Internationally, the Hornet's appeal grew as nations recognized its exceptional capabilities. Countries including Canada, Spain, Finland, and Malaysia incorporated variants of the Hornet into their air forces, making it one of the most widely operated carrier-capable multi-role fighters in the world. Its adaptability and reliability made it a preferred choice for both naval and land-based air forces. A key factor behind the Hornet's success lies in its innovative design. The aircraft features a twin-engine, mid-wing configuration optimized for carrier operations, where robustness and reliability are paramount. Its two General Electric F404 GE402 afterburning turbofan engines provide a combined thrust capable of pushing the Hornet to speeds up to Mach 1.8 at 40,000 feet. These engines were designed for operability and ease of maintenance, a departure from earlier, more temperamental power plants. Remarkably, the F404 engines can be replaced in under 20 minutes by a four-person crew without special equipment, reducing aircraft downtime dramatically. Aerodynamics play a vital role in the Hornet's agility. The aircraft's trapezoidal wings have a 20-degree sweepback on the leading edge, combined with full-span leading-edge flaps and trailing-edge ailerons that double as flaperons. Additionally, the Hornet's canted vertical stabilizers and oversized horizontal stabilators contribute to its excellent performance at high angles of attack. These features allow the Hornet to execute tight turns and maintain control even under extreme maneuvers. The aircraft's flight control system, a digital fly-by-wire setup, amplifies pilot inputs and adjusts control surface movements dynamically, improving handling and safety. The Hornet also pioneered the use of multifunction cockpit displays. This technology allows pilots to seamlessly switch between fighter and attack roles during a mission, with displays adapting to provide the most relevant information. This force multiplier capability means a single Hornet can perform diverse tasks, from fleet air defense to close air support, without compromising effectiveness. The digital multiplexing avionics bus integrated into the Hornet's systems was revolutionary for the U.S. Navy, simplifying upgrades and maintenance. Beyond design, the Hornet's versatility shines in its operational roles and weapons systems. The aircraft is capable of carrying an impressive array of munitions on 9 external hardpoints, with a maximum external load of 13,700 pounds. It can deploy air-to-air missiles like AIM-9 Sidewinders and AIM-120 AMRAAMs for dogfighting and fleet defense. For ground attack, it carries AGM-65 Maverick missiles, laser-guided bombs like the Paveway series, and precision-guided JDAMs. Anti-ship capabilities include the AGM-84 Harpoon missile. The Hornet can also deliver nuclear ordnance such as B-61 and B-83 bombs, underscoring its strategic flexibility. The aircraft's gun system consists of a 20mm M61A1 Vulcan rotary cannon mounted in the nose, with 578 rounds on board. This cannon remains a lethal weapon in close combat scenarios, particularly when missile engagement is not ideal. The Hornet's electronic warfare suite includes radar warning receivers and countermeasure pods, enhancing survivability against enemy threats. Targeting pods such as the AN/AAS-38 Nighthawk and later the ASQ-228 AT Flare provide laser designation and infrared targeting capabilities, vastly improving strike accuracy. The Hornet's combat debut came in 1986 during the U.S. bombing campaign against Libya. Its performance in precision strikes and fleet defense validated the Navy's investment. The aircraft went on to play crucial roles in the 1991 Gulf War, where it executed air superiority and ground attack missions across Iraq and Kuwait. In the 1990s, Hornets participated in NATO operations over Bosnia and Kosovo, demonstrating adaptability in complex conflict environments. During the 2003 Iraq War, A-18s provided close air support and interdiction, showcasing their continued relevance in modern warfare. Throughout its career, the Hornet also served as the platform for the U.S. Navy's famed Blue Angels flight demonstration team from 1986 until 2020. The Hornet's precise handling and reliability made it ideal for the demanding aerobatic maneuvers that captivate millions worldwide. In the late 1990s and early 2000s, the FA-18 Hornet underwent evolutionary upgrades culminating in the FA-18EF Super Hornet. Larger and more advanced, the Super Hornet replaced both the legacy Hornet and the venerable F-14 Tomcat. Despite this, the original Hornet remained a critical asset for the Marine Corps and Allied nations well into the 21st century. The U.S. Navy retired its last legacy Hornets in 2019, transitioning fully to newer platforms like the F-35C Lightning II. The Hornet's reputation for reliability and ease of maintenance is remarkable. Its mean time between failures is 3 times that of other Navy strike aircraft, and it requires half the maintenance hours. This efficiency benefits carrier operations, where aircraft availability directly impacts mission success. The Hornet's fixed air intakes, unlike variable geometry designs on aircraft like the F-14, reduce mechanical complexity and maintenance demands. These design choices reflect a pragmatic balance between performance and operational cost. Globally, several air forces continue to operate the Hornet, with various upgrades and local modifications. Canada's Royal Canadian Air Force fields 86 CF-18s, a variant of the Hornet, while Finland, Spain, Switzerland, Kuwait, and Malaysia also maintain active Hornet fleets. These operators value the aircraft's multi-role capability and proven combat record. For instance, Finland's 53 FA-18Cs and 7 FA-18Ds form a core part of its air defense strategy, equipped with modern targeting pods and radar systems. The Hornet's legacy is not without tragedy. Several notable accidents have occurred over its service life. In 2008, a U.S. Marine Corps FA-18D crashed in San Diego, killing 4 civilians on the ground while the pilot ejected safely. Another crash in 2012 near Virginia Beach injured 7 people but saw both crew members survive. In 2016, Captain Jeff Cuss, a Blue Angels pilot, died during a training exercise in Tennessee, performing a complex maneuver. More recently, in 2023, a Marine Corps FA-18D crashed shortly after takeoff from Miramar, resulting in the pilot's death. In 2025, a Royal Malaysian Air Force Hornet caught fire on takeoff, marking the first loss in its aging fleet and prompting investigations. Despite these incidents, the Hornet remains a symbol of engineering excellence and tactical versatility. Museums around the world display Hornets, preserving their history for future generations. Notable aircraft include the first FA-18A built in 1978, now at the U.S. Naval Museum of Armament and Technology, and several Blue Angels Hornets exhibited in museums across the United States. The A-18 Hornet specifications reflect its balanced design. It measures 56 feet 1 inch long, with a wingspan of 40 feet 4 inches when armed. Its maximum takeoff weight reaches nearly 52,000 pounds, supported by its powerful twin engines. The Hornet can climb at an impressive rate of 50,000 feet per minute and operate at altitudes up to 50,000 feet. Its combat range varies depending on mission profile, but generally extends around 400 nautical miles for air-to-air missions, with ferry range exceeding 1,800 nautical miles with external tanks. In terms of avionics, the Hornet incorporates the Hughes AN/APG-73 radar, a weapons system computer, and radar warning receivers that enhance situational awareness and survivability. The integration of targeting pods and electronic countermeasures allows the Hornet to operate effectively in contested environments, detecting threats and engaging targets with precision-guided munitions. This blend of technology and capability exemplifies its multi-role nature. The Hornet's impact on military aviation is profound. It demonstrated that a single airframe could successfully combine fighter agility with attack versatility, changing how navies and air forces approach air combat. Its design principles influenced future aircraft development, including its own successor, the Super Hornet, and even experimental NASA projects that explored high angle of attack handling using thrust vectoring. Today, the Hornet's legacy endures not just in museums or retired squadrons, but in the continued operation by Allied forces and in the lessons learned that shape modern fighter design. Its adaptability, reliability, and combat record make it a benchmark for multi-role combat aircraft worldwide. The Hornet's story is a testament to innovation meeting operational need, creating a fighter that truly earned its place in aviation history. In summary, the McDonnell Douglas F/A-18 Hornet stands as a hallmark of tactical flexibility and engineering ingenuity. From its origins as a Navy adaptation of a lightweight fighter prototype to its distinguished combat service across multiple conflicts, the Hornet's journey reflects decades of dedication to aerial excellence. Its design, versatility, and legacy continue to inspire the future of naval and multi-role aviation. The Hornet isn't just a fighter jet. It's a symbol of what can be achieved when innovation and purpose come together in the skies.